seen it, actually. That's right there.
Before we get started, I'll just do a quick
Oh,
everywhere from web apps or cloud transformation, whatever you're interested in. We want to give a quick thank you to our sponsor, Slalom, who provides the space for us and gets pizza and beer. And then also just highlight some of our upcoming talks. So on November 6th, we're going to have Doug Meibel in here, and he's giving a talk on deploying web apps to AWS. So that should be a really fun talk. And then in December, we're actually doing a really fun event. It's going to be a holiday lightning round. So we're probably going to have like 8 different speakers in who are all giving short talks, 8 to 10 minutes. So if you're interested in giving one of those, let us know. Or if you know someone who should give one, nudge them. And you can message us on Meetup. Yeah, but without further ado, Kyle is going to teach us how to write clean code.
hopefully. I actually gave a very condensed version of this at the lightning talk last year. So super easy. Spoiler alert, they give you prizes at the end if you contribute. So if you want to give a presentation, please step up, connect with the meetup group like she was talking about. I'm Kyle Banner. I work for Slalom. Tonight I'll be talking about clean code, which, as I already showed you, is this book. So nobody's read this book. That's all right. That's why you're here. Yeah. If you had read the book, I mean, you could be giving this talk, I guess. This is me. I got a little cheeky with the alliteration. Hopefully you guys can see that. Are you guys able to see that in the back? Yeah? Okay. I got my degree in electrical engineering. I had a bunch of software internships in college. And my first job out of college was electrical engineering. I figured out that I hated electrical engineering more than I hated software. So now I write software for a living. I have experience mostly in .NET, Node.js, React Redux. C++ is up there, but I don't want to talk about it. Those other things too. So today's agenda is we're talking about clean code, the book. It is close to 450 pages long, but don't let that intimidate you. It's a quick read. There's pictures. It's great. And it's not dense, unlike the other book that I'll briefly talk about that I brought tonight too. It's very straightforward. There's no fluff in there either. So this is the guy that wrote it, Uncle Bob, Robert Cecil Martin. He's actually giving a talk, if you Google it, in Fort Collins, coming soon. He is more of a talk about this book, The Clean Coder, which is kind of a code of conduct for developers and how to interact with Agile teams and things like that. He is one of the founders of the Agile Manifesto. So if you work on a Scrum team, you can thank this guy that you don't work on a waterfall team. And we'll get started with the first quote. So I only took one programming job in college, or one programming course in college, and it was taught by this guy, the creator of C++. His name is Bjarne Stroustrup. He sums up this book in 2 sentences. He says, I like my code to be elegant and efficient. Clean code does one thing well. That's a concept that we'll keep coming back to throughout this entire presentation, which is the single responsibility principle, the S in solid. How many of you have heard of solid? It's good. So he goes on with the quote. I won't read all of that to you. You guys can read it. So he talks about what bad code is, right? It has muddled intent. You can't tell what it's doing from reading it. You should be able to. So this is solid. The S in solid is the single responsibility principle. It's in blue up there because it's special. It's the one that we're going to talk about the most tonight. One way to say it is that it has a single responsibility. Another way to say the single responsibility principle is to say that it has one reason to change. So each instance variable, each method, each function, each class that you write, each service should, in an abstract way, have one reason to exist. The open-close principle, software entities should be open for extension, but closed for modification. So you should be able to extend the code that you write. You should have an additive approach to the code that you write, but you shouldn't outright change the code that you write. Because in object-oriented structures, objects depend on other objects to do things, right? So we have this highly interdependent relationship between these objects. If you outright change what an object is doing, then it will impact the rest of the tree of your application. If you do find yourself wanting to directly modify the object that you're interacting with, it's a good idea to just rewrite it. Next is the Liskov substitution principle. Subtypes should be able to replace base types. We won't go into this too much. This will come up again later. But you should be able to switch out parts of an inheritance chain with each other and not completely modify the correctness of the program. That's confusing. It takes a while to grasp, but design by contract is a very similar concept where you design interfaces between systems that have a contract with each other. And if you replace the underlying system but keep the contract the same, everything should be fine. So the I is the interface segregation principle. We want many client-specific interfaces or many service-specific interfaces rather than one massive interface. So one massive anything is always a bad idea. And just the concept of abstraction interfaces is something we'll come back to later as well. It doesn't have to be the software type interface, right? It can be importing an NPM module and putting that behind a file so that when you call that NPM module, you're actually calling the file itself rather than the NPM module directly. Because Moment.js, for example, is falling out of favor because people don't want to import Moment and pass around this massive object everywhere because it's not tree shakeable, right? You can't break down Moment. You have to import all of Moment when you want to use Moment. So if you put Moment in 200 files in your application and you heavily depend upon Moment, when Moment has a vulnerability or somebody decides that they don't want to use Moment anymore and you want to switch it out for date functions, which is tree shakeable. Like I said, the book concentrates on just got sick of trying to explain the single responsibility principle all the time. So we'll get into more about why names will betray you later on and what some bad names are and some guidelines. But if you have to use and or in your name, it means that you're doing more than one thing. It means that you're doing at least two things, right? This isn't in the book, but this is something that I did at my last company. We very nerdily challenged each other to write 4 lines per method, a max of 4 lines per method, right? Doesn't apply to things like markup or switch statements or anything like that. But try to write the least code that you can in the smallest chunks that you can, and you're well on your way to adhering to the single responsibility principle. This concept of dry. Who's heard of dry? So there's a quote in the book that says, duplication may well be the root of all evil in software. In that if you have two software entities that do roughly the same thing, shaking his head in the back, he knows, then both of those are going to bifurcate, right? And travel down different logical paths. So when you call one of them, the person that is consuming that software entity is going to think that it does the same thing as the other one, and they're interchangeable, when they're not. And so you have, there's a word for it in the book. We'll get to it later. You have unexpected results, essentially, where one software entity should be doing the exact same thing as the other, and it's not. So don't repeat yourself. Keep yourself from going down that path in the first place. Make meaningful distinctions. I love this. This is probably my, if you were going to take away one simple thing from this presentation tonight, let's do this. Because I hate seeing things like info and data in code. Everything's data, everything's info. Those words are meaningless. Manager and processor, classes manage, classes process data. Customer and customer object. And JavaScript, if that's the language you're using, everything's an object. How is customer object different from customer? They're noise words. Don't use them. Okay, this is what I was trying to think of earlier. Side effects. I want you guys to look at this code. Hopefully you can all see it. It's Java, so, but it's fairly straightforward. I want you to see if you can identify the side effect that's happening here. So it's a class with one method called checkPassword. I'll give you some hints if we're lost. CheckPassword should be, oh, go ahead.
It's finding a user, and then it's also decrypting a user's password, so it's doing multiple things. I don't know if that's the question.
No, it's fine. That's a good way to start. So we're checking the password, right? So naturally, we probably need the user. We're still just doing one thing if we go get the user and decrypt the password, right? Because we have to do those things to check the password.
Is it the session initialize this example?
Exactly, yeah. So this line here, session initialize. So when I called this function, I thought I was checking a password, right? But what really happened is we initialized the session. And then later on in the code, we also initialized the session. So because I chose to import the user validated class and call the checkPassword function, I now have two sessions. This is real code. I said but this is code from Uncle Bob's days from a program called Fitness. But this really happened. They had a few sessions where back in the days where you had a sticky session instead of just like token-based sessions, they had people that couldn't maintain their logins. They would suddenly be logged out for no reason. This was the reason why. Because at some points you needed to check a password when you were already logged in still. So, command query separation. So this, I'm not too deep into this, but as a concept, it totally makes sense to me. You either want to get data or you want to modify data, right? You shouldn't really be doing both on a conceptual level. So a lot of the times we do, but they're from third-party libraries or they're behind an interface that necessitates that. And that code's under test, so that's fine. But when we're writing our business logic, we should separate the actual getting of that data and the modification of that data. That's what command query separation is all about. I really like this concept too. I hate seeing functions with 8 arguments because it takes forever to build up the call to that function. So the ideal number of arguments, according to Uncle Bob, and I think it's a good rule of thumb, is 3 or less. Really try to get it down to 2 or less. So if you're creating a function or a method, then if you have these 8 arguments that you have to go find what each one of the types are and how to structure them, it's going to take you forever to call the function. Whereas 3 or less, it probably won't take you that long to consume what you're trying to consume. Don't push your first draft. So I pushed my first draft in 2013 all the time. Like I got to a point where it worked, it was tested, that's all I cared about. It's out, it's done. Don't do that. We should treat software like we treat term papers. He doesn't say this in the book, but this is conceptually how it works for me. You're writing something that's going to live on, hopefully, for 5, 10, 20 years, right? If the company is successful. We want to be careful with the way we write our code. We want to refine our code over time to meet the concepts that we're talking about tonight. If you push your first draft, see if we got the quote here. Yeah, come out long and complicated, right? You're just trying to get it done. It's almost like working under duress, right? You're just trying to figure out the problem and get to a workable state. Usually that code is not great. Once you understand the problem, once you have it working, once it's in a remote repository, it's not going anywhere. Make it easier to read for your coworkers and for future you. I've been very guilty coming back to my own code, not recognizing it, blaming it, seeing my own name there, and having to look inwards, having to think about how I view the world. You know? I like what he says in the end here too. I don't write them that way to start. I don't think anyone could. Clean code is a thoughtful process. You have to apply thought into something that's difficult already. Comments or failures. This one, it might be controversial. It was controversial the first time I gave this presentation anyways. People love their comments. I, however, hate comments, and I'll tell you why. It's to compensate for our failure to express ourselves in our code, right? Like if we write code that needs further explanation, it's like a joke, right? If you have to explain the joke, it's not funny. If you have to explain the code, it's probably not good code. It's not a cause for celebration because of this. This is another big point I want you guys to take away. Inaccurate comments are far worse than no comments at all. What's up?
How does that work when you're dealing with like legacy code? Because you're not like expressing yourself, you're just dealing with some bullshit that's external.
So yeah, that's a very good point. There's a book called Working with Legacy Code. It's probably equally as long, right? But it's the comments in the 90s and like early 2000s were the jam, right? Everybody wanted to write a book for every line of code that they wrote. The problem is that 2-3 developers later, extending that code or maybe even directly modifying that code, they don't change the comment, but they change the code, right? So now it doesn't do the thing that it's describing, that's being described by. So if you find yourself needing to write a comment, apply other clean code principles until your code is more expressive. I haven't read, I've thumbed through the Working with Legacy Code book, and I think one of the concepts in there is don't trust the comments, like only trust the code, because that's your source of truth, right? Like the comments could be stale, the comments could be flat out wrong. The comments don't compile. That's a much better way of saying what I'm trying to say. So these are some of my opinions. He does talk about some of these in the book, but most of these are Uncle Bob. I did throw some of my own in here. I really like regex comments because I never took the time to learn regex. So, because there's a million ways to figure out what regex does online. So I never learned regex, so if you write a regex statement, just like put a very short note about what it does off to the side. That's great. If you have some strange business logic that is intended to help the business in a very specific way, write a succinct comment about it, right? Like say that this is important because we wanted our truck to never turn right. We wanted it to turn left 3 times. So succinct clarification. To-do comments, I don't know if I really agree with that. So to-do comments just kind of litter the code. Uncle Bob put it in his book. I don't agree with Uncle Bob about everything. So do it, don't do it. It's up to you. Amplification. So if you can't correctly express through naming your code entities that this is a very important piece of business or of logic to our business, then throw a comment next to it. Just say this is extremely important because X, Y, and Z. I don't think that's a terrible comment. These, however, are terrible comments. You guys can just read through these. I don't like using swagger in a language that doesn't have reflection, especially in a language that doesn't have types, because you're doing all the work anyways, right? Like, there are plenty of other ways to document what you're doing, either in Confluence, or if you're writing an API, maybe make a Postman collection and share that with your team, right? That's a living functional documentation for your API that you're writing. Your eyes skip over them. So nobody's ever going to read these comments, right? What's up?
Yeah, I was curious, what about like integrated Swagger documentation? So you see different variants of that for like, it will generate the Swagger documentation based on code?
Yeah, so I guess I was specifically talking about languages that don't have reflection, where you have to write the comments to generate the Swagger documentation, right? Like, it looks a lot like this, and Uncle Bob didn't have Swagger back when he wrote this book, but it looks a lot like listing out the arguments in a big comment block, right? Whereas if you're working with like Java or C# or whatever, where you can just generate the Swagger doc, that's fantastic, don't get me wrong. But where you have to basically write out the Swagger document through many different comments, I don't think it's worth it. Formatting. So Uncle Bob has some very specific ideas about horizontal and vertical formatting. So I was telling some of you guys before this, when we were drinking in the kitchen, I have a horror story where I opened a React file once that was 3,200 lines long, and had duplication everywhere, not dry, not clean code, not anything, because if you have a file that's 3,200 lines long and is not markup, is not like a necessarily long piece of code or structure of code, right? It's going to be violating these clean code principles. So I refactored that one 3,200 line file into like 11 or 12, 200 or less line files. And because I was reading this book again at the time, I was looking for a guidepost about how long should the file be. So I took out so much code in that file because the person that wrote like getting its code everywhere. I mean, there weren't like function calls. It was just trying to get something done and get it for, right? So vertical formatting is important. I would rather work with the files to the left of this graph. So we have a logarithmic scale over here, 1 to 10,000. JUnit, I forget what this is called. I think it's just the average, is between, let's say, 20 and 100 lines long, right? With the upper variant, or the upper extreme being 400 lines, right? So Tomcat, on the other hand, has files that are 4,000 and change lines long, right? These are all well-established frameworks. Like, these are all frameworks that are around when Uncle Bob wrote this book, I think in the 80s, and that still exists today. But I would rather work with the ones on the left side of the scale if I had to modify the internals. Horizontal formatting. So again, he wrote this back when you had like CRT screens, right? Like the block screens. 120 character limit. We can probably do more than that these days because our laptops are widescreen, our TVs, our monitors are widescreen, but don't go nuts. Horizontally tabling things is also usually a bad idea. If you want to horizontally table, so what I mean by that is sometimes like in Node.js imports, you'll see import the thing, and then from will be vertically aligned with all the other imports, right? From moment, right? Import moment from moment. But the froms will all be aligned. It's not a good idea because it doesn't read naturally. Most people are going to have to go highlight the entire line to understand what's being imported from what. If you're tempted to do that, he says length of the instance for our lists. So in Java, sure. But you're doing too much in that tabled block of code. Does that make sense? I forget what this graph is from, so it's just a pretty graph. Train wrecks. So this is a concept I see all the time in Node.js. How many of you have seen cannot do something of undefined in Node.js? See it all the time, right? It's because of train wrecks. Train wrecks are when you chain, and like BDD frameworks are a separate thing. They're great for tests. You should use those. But when you're writing application code and you're chaining calls to one another, if any one of these fails, it now becomes way harder to figure out what happened, right? So if get scratchdir is undefined, you're going to get an error that says cannot get absolute path of undefined. So break them up into different variables that explain what you're doing, and it'll be way easier to debug.
So like the law of meter, like don't break that, like your neighbor can only know about its neighbor, so you don't like the chain. Is that kind of like the same concept?
Yeah, it sounds like it. I've never heard that, but it sounds like the same concept where chaining, he calls it train wrecks, but this book was written over 20 years ago, so probably evolved to a different name by now. Chaining is what I've heard it called. Chaining in general is bad. If you're using a BDD framework, it might not be that bad. What's up?
Quick comment on that. Like try catch blocks and stuff like that. If something fails halfway through, right? You're kind of out. So, and I'd like to say like doing another function in the return block. What should be the successful result of function one? The same sort of deal, right?
Yeah, just in general, if you're doing a try catch, maybe try one thing and catch it, right? And if you're having multiple function calls within the same function, you know, we went to this code example earlier. Like, I don't think this is bad, right? But we're calling multiple functions here. This probably could be split up more to adhere more to the single responsibility principle. So like if you try catch, get phrase encoded by password, and decrypt in the same try catch block, maybe you should break it up into two, you know? Okay, another big exclamation point from tonight. I talked about this already, but if you import an NPM library that you're going to be using everywhere, it might be a good idea, especially if it's just a widely available NPM library like Lodash, Moment, date functions, whatever. Put it behind an interface. Put it conceptually behind an interface, right? So not the actual software entity interface, but put it in a file called, you know, dates or date formatter, right, for a moment. And import moment once in that file so that everywhere else in your code, you've established a contract, right? Liskop substitution principle with design by contract. You've created this contract now that you care about, right? You're not aligning your business logic with what Moment's doing. You're ruling your own business logic. So you create this contract internally in your own program. You modify the Moment response to fit that contract. And now when you want to switch out Moment for date functions, then it becomes way easier. So you have to modify that one file instead of modifying 200 files. So he goes a little further here. Java 4 did not have generics, so you had to call the concrete instance of map every time you wanted to use it. And then in Java 5, you can use generics, so you could just map two things to each other much more easily. This is a way of being able to switch between major versions of the language you're using. If you go crazy with interfaces and put like map behind an interface. I've never seen this done, but I don't think it's a bad idea. If you know that a change is coming up in a language that you're using, like in .NET Core, fairly new, right? Because they restarted from .NET 5 or whatever. And you know that this language is nascent. It might be a good idea to abstract some of those language concepts so that you aren't tied to that specific version of that language moving forward. Unit testing. So a lot of people are big proponents of making their unit tests clean, and I think that's great. I think you should make your unit tests clean, but only to a certain extent. This is where you kind of like flip clean code on its head and say that tests should be damp, not dry. So damp means descriptive and meaningful phrases, whereas dry means don't repeat yourself. So if your test suite can be more expressive by duplicating code, it's not a terrible idea to duplicate code to express the intent of those tests. I don't generally like seeing helpers in a test that have like a massive inheritance chain. It just causes issues. Because when you look at the tests are 3 lines long, right? But those 3 lines are calling the helpers methods, which are also calling this deep inheritance chain behind it, right? So you're not clearly expressing what you're doing in that test. You're obfuscating the code and making your test code look like your app code. I think a lot of people, I think this is another controversial topic, right? Structuring tests well is a well-intentioned thing most of the time, but it often obfuscates the intent of those tests. So descriptive and meaningful phrases. Dry is not terribly important in your tests, but don't like duplicate everything everywhere in all of your tests. Like that's a bad idea too. These are some of the concepts that I really like that helped me with unit tests in the beginning. Build, operate, and change. Another way of saying that is AAA, arrange, act, assert. Having 1 assert per test helps clarify the intent of your test. And single concept per test is probably the most important, right? Like you don't want to have 1 massive unit test for a file. You want to have many unit tests for many functions in 1 file. So I've actually seen this happen. He's referring to unit tests here. The state of their unit tests at FitNess got so bad that they had to remove them as a blocker for releasing code, which in a normal CI/CD pipeline, you want to pass your tests before you go to production, right? And so what happened was they were now scot-free to release whatever code that they wrote without testing it. It's a terrible idea. I've seen this happen in other places, not with unit tests, but with integration tests, particularly UI automation tests, right? Like Selenium is notoriously brittle. Cypress is great these days, but some work to do there. And removing any part of your test suite, your test automation framework is always a bad idea. You should refactor your tests to get them back into a usable state, or take out the tests that are brittle and refactor those in the meantime. But taking out an entire suite and just being able to go to production all the time with no tests is a bad idea. This is a completely different concept now. How many of you have ever talked about premature optimization or gotten away from optimizing your code before it's even written? So in a lot of Scrum meetings, I'll see people talking about, well, we've got this thing on the horizon, this data change, or this new infrastructure coming in, or we have to merge with this other company, so we have to rewrite everything in Bootstrap, right? It's not today's concern, so you shouldn't be concerned with it today. You should be concerned with it at the last possible moment that you possibly can before you start writing code, because you'll know more, right? I think Bill Gates had a quote once. He said, "The best software developers are lazy," and that's the concept he was trying to get across. Is that if you wait until the last minute, you're going to know way more than if you try to plan out a year ahead. Uncle Bob uses the analogy of a 6-lane highway going through a small town because the town anticipates growth, right? I came from Austin. I would have liked the 6-lane highway, but I understand why they only had a 2-lane highway through the middle of town. It's because nobody anticipated that boom, right? So build it when you need it, and only at the point that you need it. So composition over inheritance. Who's familiar with this? Composition over inheritance. Yeah. So this is kind of a complex topic. There's a great, I hate citing Wikipedia articles, but there's a fantastic Wikipedia article about composition over inheritance. I recommend go read it if you've never heard the concept before. But the concept of the very traditional inheritance chain of you have a base class and everything inherits from that base class is flawed in a few ways. And if you have many classes that all have a single responsibility, and you compose all of those classes together into one class that can do, like a service class essentially, that can do those many things, it's usually a much better scenario than having a massive inheritance chain to build up to the point where you want to do that service level thing. So this is a difficult concept to talk about tonight, but he does mention it in the book, so I wanted to at least make everybody aware of it. So encapsulation. Encapsulation is the concept of only making public what you need to make public, and worrying about the tests when you need to, right? Because it's hard to test private things. But encapsulation hides all of the methods that help your class do a single responsibility thing, and exposes like the getters and setters that you want to expose. So encapsulation is the concept of only exposing the things that you want exposed. It ties very closely with cohesion. Cohesion is a software entity is cohesive when it shares similar concepts, right? When you have a class that concentrates on one thing, and all of those things are related conceptually, it's said to be a cohesive class. Your instance variables, your functions, or in Node.js, like a file that you want to write. I keep coming back to moment, but let's talk about it again. Like your date formatter file, right? You wouldn't want to put, let's say, a user in your date formatter file. You wouldn't want to establish what a user does in your date formatter file. Doesn't make any sense. They're not two cohesive concepts. Whereas if you wanted to format, ISO standard, and then also format what the United States uses for their date standard, then those two things feel like they belong in the same conceptual space, right? So it's also this concept of emergence. Code is said to be emergent when it runs all the tests. And I really like how he put it in the book. Systems that aren't testable aren't verifiable. So he was coming back to that concept of yanking out the tests before going to production so that you can just release whatever you want. You have no way of knowing that your application does what you say it does. Should never be deployed if you can't verify it. An emergent system contains no duplication, expresses the intent of the program, and minimizes the amount of code that's written. It's another way of saying clean code. Organize and anticipate change. So he has a whole chapter on how to avoid this concept of premature optimization, right? How do you do that? So making the code in each class excruciatingly simple, having unit test coverage 80% or more. Classes are open for extension, closed for modification. So we're coming back to that OCP principle, right? And from Solid. And dependency inversion is a way to depend upon your abstraction. So depend upon your file that calls moment instead of depending upon moment directly. I didn't do this. It was a side app that I was writing. I was writing this finance thing. I thought was going to make me a millionaire. Turns out it didn't. One of the many reasons was because I called Yahoo Finance directly. Is anybody here familiar with the Yahoo Finance API? it was this thing, back in the day, it was amazing. You could call just a regular RESTful API with no authentication whatsoever, and it would return you the stock ticker value of whatever. You could get a stream as well of, say, Apple or Microsoft or whatever. And so I found this, and I was like, this is fantastic. I'm going to use this and create my own app. And then one day, Yahoo Finance got acquired, and they literally flipped a switch, and it's not available anymore. So what happened to me was I no longer had my service provider, essentially, right? And I sprinkled Yahoo Finance URLs everywhere in my application. So the application died, and I never touched it again. But if I had put an iStock exchange, so an interface stock exchange concept into my program from the beginning, and called Yahoo Finance behind that, and created my own contracts for business logic that related to the rest of my application, I might be a millionaire. I don't know. Okay, so finally get to, how are we doing on time? Good, okay. So this is a concept from domain-driven design. I don't know which book was written first. I think Clean Code was, but domain-driven design is an impenetrably dense and difficult to read book. I have not read this front to back. I know most of the major concepts. I've thumbed through it. One of the major concepts that I love is really difficult to do without types. If you're not writing in a typed language, like Node.js, like vanilla Node.js. You can stand up an entire domain of what he calls POJOs, or POCOs. Plain old Java objects is what they're called, or plain old C# objects, because C# is basically Java. You can stand up all of your business logic in a domain, and effectively, you won't have an app, but what you'll have is a solved problem domain. And what I mean by that is, again, if you're a transportation company, you have the concept of your transporters. You have the concept of the people that want to use your transporters, so like your e-com users, I guess. And you have the concept of space, and you have the concept of packages within that space on those trucks, right? And you stand all of those up, and you get them all talking to each other. You've solved your problem domain by separating out the concerns for each one of those software entities, right? All the other stuff is just normal software stuff, like getting it stood up behind an API, making a front end, making a database. Once you have those objects that are well encapsulated, that are conceptually cohesive, you've solved 90% of your business problem. So I don't expect anybody to actually read these, but I went to the PDF of Clean Code and took out the domain-driven design concepts that I found. There are more than this. I just wanted to show you that these two go hand in hand. Domain-driven design and Clean Code in an object-oriented programming language are two very good concepts to understand. So another way of saying a lot of what we said tonight is always use the simplest thing that can possibly work. Write the least code possible. Be expressive with the code that you do write. Don't use filler words. Don't be funny in your code. Be funny with your coworkers. Don't be funny with your code. Don't use the simplest thing that you can possibly use. Express yourself. And so he doesn't talk a lot about this. This is my last slide. But I think this is one of the bigger concepts in the book. That's why I wanted to end with it. Care is a precious resource. You can tell, you guys are all here tonight because you care, right? You can tell who among your coworkers doesn't really care, right? Because in part of the code that they write, right? If they push up something that barely works and it is their first draft and they haven't taken the time to refine their code, they don't care. Somebody cares when they've taken the time to keep it simple and orderly. They have paid appropriate attention to details. They have cared. That's, if anything, as a concept, the biggest concept I want you guys to take away tonight. That's it. Any questions? Yeah, I could probably host it on the meetup, right? Yeah, let's see what I can do.
You mentioned that sometimes people put noise words in variables. What noise words have you experienced?
So I've seen all of the things that I mentioned there. Let me go back to that slide.
See, I think you said that that was the most important part of it.
Yeah, I said every slide was super important, so. Yeah. But this, like, as an easily take-awayable thing tonight, right? Something that you can just go not do anymore. Stop using words like info and data, first and foremost. Manager and processor and object, or like putting the name of the type after the variable, right? So name string. It's not helpful. It takes away from kind of the logical flow of reading the code. All names should be string. And if you do have a name that's an object for any reason, any developer can see that, oh, this thing's a string or this thing's an object. So there's no point in writing those words. What's up?
The concepts or chapters that you read at first, like when you first read it, that were like, yeah, I'm Robin Hood, and now you're just like,
What was the thing that I said? In particular, that's a very, he didn't have a whole chapter on the comments, but else, the tests. Yeah, so this one is probably the most wishy-washy, right? Like you want your tests to be clean. He makes a very strong argument that unit tests should be necessarily not clean. But then he caveats it with all these different things saying that what I mean by not clean is descriptive and meaningful. You want your tests to be the most expressive code that you write, right? Because that's your AC essentially. That's your acceptance criteria. Like you want to put the most significant parts of your business logic under test, under the most test. Yeah. So if you aren't the cleanest in order to be expressive in your tests, he considers that a good thing. I do as well. This one's just kind of like, all code should be clean, but if you sacrifice cleanliness for expressiveness in your tests, it's not a bad thing.
follow up, like, have you ever been scolded for following any of these principles?
Oh yeah, especially this one. Like the one that we're talking about right now. Like this one, so a company I worked for had a long inheritance chain of helpers for tests, right? And I changed the base level of those helpers. And they were calling the base level of the helper in some files, but then they're also calling the inherited types in the other files as well. And so it made it really difficult, because I changed the base file and that was fine. Helpers weren't terribly impacted by my change, but the helper files, because they extended the code from the base file, it made it really difficult to go change all the tests that called those helper files. It's a very long way of saying inheritance in tests is tricky. Like, because if you need to modify or extend your test files on a fundamental level, then breaking that inheritance chain becomes difficult.
Like, what kind of pushback did you get? Why did you do this?
Oh, well, it was mostly about like on a PR, I would say that like you're making this too clean. Like I have no idea what this test does, and there was a little pushback there because it was a good thing that they make their code clean, right? So we got through it. It's fine.
So let's say you create an instance of a AKC customer class, and you've got that variable that you assigned to. What would you call it? Because obviously just customer doesn't seem very descriptive.
I would try to call the customer. So if you're grabbing the customer object, I would try to call the customer whatever. How do I say this? The context that you're in, right? So if you're like in an e-com context, or if you're like in an employee context, I would call it like e-com customer or employee customer, to be as descriptive about like not only the thing that you're consuming, but also the context that you're in, right? So I feel like that's kind of a cheap answer, but but
Do you have like an example of some customers you maybe in the past, like new customer, updated customer, do you follow patterns like that?
yeah, So not at any place I've gone to as Solemn, but at a previous employer, we had this user object that just grew and grew and grew and grew over time. And it's a pretty common thing to happen because everybody's a user, right? So I would have broken those users up in that inheritance chain, or maybe even composed a user from several different concepts, including user, to identify the actual user that I was calling at the time, right? Because whenever we had to build up the new user object, we had to pass in like 10 variables or more. I think it was a lot more. And it was behind an interface, but it doesn't matter at that point, right? Like you still have to build up this concrete thing that has 10 variables. And every time we had to interact with the user, it was a giant pain. So, which is all the time.
So start with the protocol at the top, right? Which is just the raw customer. Maybe it has like a name, email address.
Yeah.
And then do extensions on that.
Yep.
Econ customer. Whatever other customer.
Yeah.
Customer.
Internal customer, like, or maybe not even internal, because that's like a keyword. So,
Well, that's
name of your
value.
company.
You're talking about value types, so you're throwing around classes left and right, right?
Yeah.
It's kind of Java based, but you also kind of throw in like copy on write and a value type versus a reference type when you're thinking about this too.
Yeah. Yeah. And creating responsible names for those and composing those without having 10 arguments or without having a ton of data necessary to compose those things is a great idea. So. What was that? Oh yeah. Let's just write binary. I don't. Yeah. Yeah.
So clean.
What's up?
Simple, maybe it's simple. When you say like don't use user data or something, if you do have something that holds user data, what would you call that?
So alongside this framework called Axios that I used to use a lot, and even in most API responses, you're going to get that data field. It's not something that you can completely get around all the time, but if you are using user data, I would maybe identify the parts of the user data in different ways and say like, user, what's that concept? Primary key, right? Because now you know you're interacting with a database concept. So like you would break down that object into the different things that it holds, right? So it's not just this blob of info anymore. It's now more consumable as like a user primary key and the user name and the user email and the user. Yeah, but the parent level would just be user because data isn't terribly descriptive, right?
Yeah, I was gonna say, we were working on the same project when I think you were reading this book and like you used it as an example because you gave this talk to our group as well. And we had an instance where it was like the top level name was user, and then within user there was an object called user data, which just was like redundant, so it wasn't really helpful.
Yeah, that would maybe flatten, if you do have the same scenario, flatten user data, so it just becomes user, right? There's no need to have user.user data. there is a need to have user.email. There is a need to have user.primary key, right? So.
What would be your opinion of like a clever solution versus like the most clean, succinct solution? I guess that level of like expressivity versus just keep it to yourself.
That's a I'm so glad you brought that up. That's a fantastic concept. Clever is the opposite of expressive, right? In my mind. You can still be clever and be expressive, but in the negatively connotated version of clever, you're being clever, right? Like you're, yeah.
You see a lot of train wrecks in clever code. Like
Yeah.
everybody's trying to put everything in one line, and so everything is chained together, and then you don't know where it fits.
So this concept that I brought up very early on, the 4-line challenge, resulted in a lot of clever code, right? Because people wanted to still have more than one concept in their software entities, but they were limited to 4 lines. So how do you do that? You got to be clever. And I think the developers that just want to be the smartest person in the room are the developers that write code that nobody can read, right? So don't be clever, be expressive. That's the main distinction that I would say between like clever code and clean code.
I also feel like with that, I've worked with developers who, like, it looked nicer because the function name, the variables were all, like, really short.
Yeah.
They would use, like, really short abbreviations for everything.
Yeah.
And I feel like this book says you should err on the side of just being verbose in your
Yep.
name, so it's super easy to know what's going on.
So that concept, because I'm an electrical engineer, comes from, I wrote that code, but under duress because I only had a few megs of memory to work with, right? So you have to be very concise with what you call, like on a microchip level, you have to be very concise with what you call things. We don't have that limitation. Maybe you did in the 80s and 90s if you were writing even a Java or like a Java-like program or OOP program. You did have those memory constraints, but we don't anymore. Just be as expressive as you can. So, anything else? Got more cold pizza and beer. Well, thanks for coming tonight.